Assalamu alaikum students, hope you guys are fine and doing well. Welcome to the past paper series. I am Shamsa Jabin, and today in this video we are going to learn to discuss Cambridge IGCSE paper 4 extended May June 2025, and here I am doing variant 1. Right, in this video we will do question number 9 of this paper. Strontium 90 is a radioactive isotope that contains 8 protons and 52 neutrons. Strontium 90 decays to form an isotope of yttrium. Wait, I will change the color. Yes, yttrium, by emitting the beta particles. Suggest how the nucleus of a stable isotope of strontium differs from the nucleus of strontium 90. Right, so in this one we just need to tell them about the stable isotopes and the unstable or the radioactive isotopes. So the one hint is, if you focus on the strontium, that is 90 and 38, if you compare both the numbers, you can see that the atomic mass is very high, right? So it's a hint that those radioactive isotopes are those which are very heavy, right? So we can say radioactive so the suggestion is radioactive isotopes are very heavy, or radioactive nuclei are very heavy, right? Too heavy or much heavy. And we can also say that in the stable one we have fewer neutrons, while the radioactive isotopes are usually excess of neutrons, right? Okay, now let's read the next question and complete the nuclide equation of the decay of strontium 90 to yttrium. Okay, so how we will know the yttrium atomic mass or atomic number. The first hint is, first we'll write the betas one. We will complete beta particles and then we will move to the yttrium. So in case of beta, we know that the beta's atomic number is -1. It's a negative radiation with the mass 0. So how we will find it? This is 90 and it is giving you a number plus 0, so it must be 90 because no one will go to the beta one. But in case of atomic mass, we know that strontium is 38 plus yttrium equals to yttrium atomic mass that we need to find out, that we don't know, plus the beta particles atomic number, that is -1, right? Proton. Okay, just rearrange the equation. We get 38 -1 will go to the other side, will give you +1 yttrium, and we will get 39. So the atomic number of the yttrium is 39. So this is our completed equation. I am removing the working so you guys check it out. Yes, okay. Now let's move to the next question. Explain why scientist limits the amount of time that they are exposed to the radioactive strontium. So why? What is the reason? Basically the reason is beta particles ionizes. The first one is we know that the beta particles have high ionization power, right? So it means beta radiations are ionizing and they are harmful to human being. Harm to human. Okay, now let's do B part. Yttrium is unstable. Okay, first strontium is unstable. Now yttrium is also unstable, and the scientist place a yttrium near a radioactive detector. The paper shows the count rate recorded by the detector of the sample, right? So this is our table where the count rates and the time are given. Figure 9.1 shows a count rate due to yttrium against time. So this is our graph, and we need to determine the half-life of the yttrium. Show your working. Okay, what we need to find out? We need to find out the half-life. Are you guys familiar with the half-life? Half-life is basically the half of time when count rate is, or time at half count rate. Right? So this is our actual main count rate, 48. So what we need to do, 48 divided by 2, right? So it will give you 24. The time at which our count rate is 24 is our half-life. This is our time 24, and we need to find out the time where this one, right? So this point you need to find out. Now we will read the table. We know that the small 5 boxes will give you 20. 5 boxes equals to 20. So 1 box equals to 20 divided by 5, so equals to 40. It means one small box is 40, right? So let's count them and find out the exact value at 24. So it is 60. This one is 60. This one is 60, and then 1 box, 2 box, 3 box, 3 box, and 3.5 boxes. 3.5 boxes we have this. These are 3.5 boxes after 60, right? So you can multiply them with 4 because 1 box is 4. 5, 4, 20, 12, 14. And we will add it in 60. 60 plus 14, it will give you 74. So the answer must be 74 hours, right? Again I am explaining it how we will calculate it. We know that this is 60, right? This one is 60, And after 60, what we have 4 boxes, right? Sorry, 3.5 boxes. 3 complete boxes and the one is half box. So just 3.5 boxes, just multiply it with 4 because we know that the single box is 4 and it is calculated from here. So solve it, you will get this answer 74. Okay, now come to the last part. Explain the difference between the count rate in table 69.1 and the count rate due to yttrium plotted on the graph. Okay, if you can compare them, all the values are greater than from the graph. In the graph we have the 48 and here we have 68. So you can compare the values, all the values on the table is greater than the one that is on the graph. So what you guys think, why this is there is a extra points or extra radiations? So in this case we can say blue color, wait, I'm changing the color, green. Okay, so basically the table contains, why it is table contains the extra radiations, because table includes background radiations, because it is drawn from the detector and detector also catches the background radiations. Radiations, while graph does not. And the second point is graph has corrected count. We can say that graph has corrected count rate. Students, I hope this question is clear. In the next video we will do the next part, the next question. Thank you. Allah Hafiz. Bye bye.